अब हम आते हैं कंडीशन ऑफ टेंजेंसी एंड इक्वेशन ऑफ टेंजेंट पे। तो सबसे पहला और बेसिक कंडीशन कि एक लाइन सर्कल को टेंजेंट है वो आता है परपेंडिकुलर डिस्टेंस ऑफ पॉइंट फ्रॉम अ लाइन से। तो अगर हम एक सर्कल और लाइन को देखें तो उसमें तीन कन्फिगरेशंस बनते हैं। तो या तो सर्कल और लाइन एक दूसरे को इंटरसेक्ट नहीं करेंगे, या सर्कल और लाइन एक दूसरे को टच करेंगे, या फिर सर्कल और लाइन एक दूसरे को दो पॉइंट्स पे इंटरसेक्ट करेंगे। तो ये केस में हम क्या करेंगे, ये केस में सर्कल का सेंटर हमें पता है, सपोज ये सेंटर है h, के, और लाइन का इक्वेशन हमको दिया होगा, सपोज ax प्लस by प्लस c इक्वल्स टू 0, और सपोज सर्कल का रेडियस है r। तो हम क्या करेंगे, हम सेंटर से इस लाइन का परपेंडिकुलर डिस्टेंस निकालेंगे। तो इसका जो परपेंडिकुलर डिस्टेंस होगा वो होगा AH प्लस BK प्लस C अपॉन अंडर रूट ऑफ A स्क्वायर प्लस B स्क्वायर। तो अगर ये D R से बड़ा आता है तो ये सर्कल और लाइन एक दूसरे को इंटरसेक्ट नहीं करेंगे। अगर ये D R के बराबर आता है तो वो केस में ये लाइन सर्कुलर टेंजेंट होगा। तो ये है आपका कंडीशन ऑफ टेंजेंसी। तो कंडीशन ऑफ टेंजेंसी के लिए हम सिंपली ये करेंगे कि सेंटर से उस लाइन का परपेंडिकुलर डिस्टेंस उसके रेडियस के बराबर होना चाहिए। और अगर आपका डी आर से छोटा आता है तो सर्कल एंड लाइन इंटरसेक्ट एट टू डिस्टिंक्ट पॉइंट्स फॉर्मिंग अ कॉर्ड। तो यहां पे दे डू नॉट इंटरसेक्ट, यहां पे ये दोनों टेंजेंट हैं, और यहां पे ये सर्कल इस लाइन को दो पॉइंट्स पे इंटरसेक्ट करता है। अभी तीसरे वाले केस को अगर देखें तो यहां पे ये डी है, ये उसका रेडियस है। तो अगर अपने उसका लेंथ ऑफ कॉर्ड निकालना चाहते हैं तो हमको पता है कि लेंथ ऑफ कॉर्ड ए बी है वो होगा 2 टाइम्स ए सी, और 2 टाइम्स ए सी का मतलब 2 टाइम्स अंडर रूट ऑफ आर स्क्वायर माइनस डी स्क्वायर। तो ये केस में जब लाइन सर्कल को दो पॉइंट्स पे इंटरसेक्ट करता है तो उस कॉर्ड का लेंथ आएगा 2 टाइम्स अंडर रूट आर स्क्वायर माइनस डी स्क्वायर। और ये केस में जब वो उसको टच करता है तो हमको अगर ये इक्वेशन पता है तो हम यहाँ पे ये पॉइंट ऑफ कांटेक्ट निकाल सकते हैं फुट ऑफ परपेंडिकुलर फॉर्मूला यूज करके। तो सेंटर से जो भी फुट ऑफ परपेंडिकुलर होगा इस लाइन के ऊपर तो वो पॉइंट आपका पॉइंट ऑफ कांटेक्ट आएगा। तो ये है आपका पहला कंडीशन टेंजेंसी के लिए। अब दूसरा जो कंडीशन ऑफ टेंजेंसी हम लिखेंगे वो लिखेंगे क्वाड्रेटिक इक्वेशंस को यूज करके। और ये बहुत इंपॉर्टेंट है क्योंकि ये कई सारे क्वेश्चंस में पूछा जा चुका है और बहुत सारे अलग अलग सिचुएशंस में आप इसको यूज भी करेंगे। तो जैसे एक सिंपल सर्कल लेते हैं, ऐसा सर्कल जिसका कि सेंटर ओरिजिन है। तो सपोज हमारे पास एक सर्कल है एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल्स आर स्क्वायर, और हमको ये कंडीशन बताना है कि ये लाइन y इक्वल्स mx प्लस सी इस सर्कल को टच करेगा। तो हमको पता है कि एक लाइन और सर्कल या तो दो पॉइंट्स पे इंटरसेक्ट करेंगे, या फिर एक पॉइंट पे टच करेंगे, या फिर ये दोनों कभी भी एक दूसरे को इंटरसेक्ट नहीं करेंगे। तो हम क्या करेंगे, हम इनके पॉइंट ऑफ इंटरसेक्शन निकालेंगे। तो उसके लिए हम y की वैल्यू यहां पुट कर देते हैं। तो ये हो जाएगा आपका एक्स स्क्वायर प्लस mx प्लस सी होल स्क्वायर, और ये बराबर है आर स्क्वायर के। इसको ओपन करते हैं तो इसको हम लिखेंगे x में क्वाड्रेटिक के जैसे, तो ये हो जाएगा 1 प्लस m स्क्वायर एक्स स्क्वायर प्लस 2 m इंटू सी इंटू एक्स प्लस सी स्क्वायर माइनस आर स्क्वायर इक्वल्स 0। अब ये क्वाड्रेटिक है एक्स में, तो अगर इस इक्वेशन के दो डिस्टिंक्ट रूट्स आएंगे तब ये लाइन इस सर्कल को दो पॉइंट पे इंटरसेक्ट करेगा। अगर ये इक्वेशन का सिर्फ एक ही रूट आएगा तो उस केस में ये लाइन और सर्कल एक दूसरे को टच करेंगे, और अगर इनका कोई भी रियल रूट नहीं आता है तो वो केस में इनका कोई भी रियल सॉल्यूशन नहीं होगा और ये एक दूसरे को इंटरसेक्ट नहीं करेंगे। तो यहां पे हमको कंडीशन ऑफ टेंजेंसी निकालना है। तो कंडीशन ऑफ टेंजेंसी निकालने के लिए हमको पता है कि यहां पे सिर्फ एक ही पॉइंट ऑफ इंटरसेक्शन आना चाहिए, तो इसका मतलब d इक्वल्स 0 होना चाहिए। तो d इक्वल्स 0 पुट करते हैं तो ये हो गया b स्क्वायर, तो 2mc होल स्क्वायर माइनस 4a हो गया 1 प्लस m स्क्वायर इंटू c स्क्वायर माइनस r स्क्वायर इक्वल्स 0। तो यहाँ से 4 और 4 को कैंसिल कर देते हैं, तो ये हो जाएगा आपका m स्क्वायर c स्क्वायर, और इसको अगर राइट हैंड साइड पे लेंगे तो इसको हम लिख सकते हैं c स्क्वायर प्लस c स्क्वायर m स्क्वायर माइनस r स्क्वायर इंटू 1 प्लस m स्क्वायर। तो यहाँ पे m स्क्वायर c स्क्वायर कैंसिल हो जाएगा, तो यहाँ से हम लिख सकते हैं c स्क्वायर इक्वल्स r स्क्वायर इंटू 1 प्लस m स्क्वायर। तो अगर ये लाइन इस सर्कल के लिए टेंजेंट है तो कंडीशन ये है कि c स्क्वायर जो है वो बराबर होना चाहिए r स्क्वायर इंटू 1 प्लस m स्क्वायर के। तो यहां से हमारे पास कंडीशन ऑफ टेंजेंसी आ गया, और कंडीशन ऑफ टेंजेंसी के साथ इक्वेशन ऑफ टेंजेंट भी आ गया कि अगर हमारा सर्कल है एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल्स टू आर स्क्वायर, और हमको एक टेंजेंट का इक्वेशन निकालना है जिसमें उसका स्लोप m है, तो ये इक्वेशन आएगा y इक्वल्स mx प्लस c, और c है आपका ये वैल्यू। तो इक्वेशन ऑफ टेंजेंट को हम लिख सकते हैं y इक्वल्स mx प्लस माइनस r अंडर रूट 1 प्लस m स्क्वायर। तो अगर एक सर्कल है जिसका सेंटर ओरिजिन पे है तो वहां से हम उसके टेंजेंट का इक्वेशन डायरेक्टली लिख सकते हैं y इक्वल्स mx प्लस माइनस r अंडर रूट 1 प्लस m स्क्वायर, जहां पे m स्लोप ऑफ टेंजेंट है और r आपका वो सर्कल का रेडियस है। अब क्योंकि यहाँ पे m है और प्लस माइनस है, तो आप जब भी सवाल को सॉल्व करेंगे तो वहां पे टेंजेंट ड्रॉ करके देखिए कि आपको स्लोप कैसा चाहिए, पॉजिटिव चाहिए कि नेगेटिव चाहिए, और आपका जो y एक्सिस इंटरसेप्ट है वो पॉजिटिव आता है या नेगेटिव आता है, तो वहां उसके हिसाब से आप यहाँ पे प्लस माइनस वैल्यू चूज कर सकते हैं। तो यहां से हमने क्या किया, यहां से हमने स्लोप से उसके टेंजेंट का इक्वेशन निकाल लिया, और यहां से अगर हम चाहें तो पॉइंट ऑफ कॉन्टेक्ट भी निकाल सकते हैं कि जैसे अब ये सर्कल है और ये इक्वेशन हमारे पास है टेंजेंट का, और ये इक्वेशन हमारे पास है टेंजेंट का, तो यहां से हमको ये इसका पॉइंट ऑफ कांटेक्ट निकालना है। तो सपोज ये पॉइंट ऑफ कांटेक्ट है x1 y1, तो यहां पे हम निकालना चाहते हैं उसके पॉइंट्स ऑफ कांटेक्ट। अब हम क्या करेंगे, उस पॉइंट को मान लेते हैं, वो पॉइंट है आपका x1 y1। अब हमको पता है ये पॉइंट सर्कल के ऊपर लाई करेगा, और अगर पॉइंट सर्कल के ऊपर लाई करता है तो उसमें इक्वेशन ऑफ टेंजेंट जो आता है वो आता है t इक्वल्स टू 0 से। तो यानी कि इस पॉइंट के लिए इसके टेंजेंट का इक्वेशन हो जाएगा आपका x x1 y y1 माइनस r स्क्वायर इक्वल्स 0। तो यहां से इसके जो टेंजेंट का इक्वेशन है वो होना चाहिए x x1 प्लस y y1 माइनस r स्क्वायर इक्वल्स टू 0। बट जो इक्वेशन हमको दिया है वो है आपका mx माइनस y प्लस माइनस r अंडर रूट 1 प्लस m स्क्वायर इक्वल्स टू 0। अब ये दोनों इक्वेशंस एक ही लाइन को प्रेजेंट करते हैं, तो यहां से a1 अपॉन a2 बराबर b1 अपॉन b2 बराबर c1 अपॉन c2 होना चाहिए। तो यहां से हम लिखेंगे तो ये x1 अपॉन m बराबर होगा y1 अपॉन माइनस 1, और ये बराबर होगा प्लस माइनस r अंडर रूट 1 प्लस m स्क्वायर के। तो यहां से x1 y1 निकाल सकते हैं, तो ये हो जाएगा आपका प्लस माइनस m r अपॉन अंडर रूट 1 प्लस m स्क्वायर और माइनस प्लस r अपॉन अंडर रूट 1 प्लस m स्क्वायर। तो ये है आपके पॉइंट्स ऑफ कांटेक्ट। तो अगर सर्कल हमारे पास है एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल्स टू आर स्क्वायर, तो उसके लिए कंडीशन ऑफ टेंजेंसी है सी स्क्वायर इक्वल्स आर स्क्वायर 1 प्लस एम स्क्वायर, और उसके लिए टेंजेंट का इक्वेशन डायरेक्टली लिख सकते हैं, वो है y इक्वल्स एम एक्स प्लस माइनस आर अंडर रूट 1 प्लस एम स्क्वायर। लेकिन प्रॉब्लम ये है कि सारे सर्कल्स जो हैं उनका सेंटर जीरो पे नहीं होता है। तो अगर हम एक जनरल सर्कल लें जो कि है x माइनस एच स्क्वायर प्लस y माइनस के स्क्वायर इक्वल्स आर स्क्वायर, तो इसके लिए टेंजेंट का इक्वेशन क्या आएगा? अब या तो हम यहाँ टेंजेंट का इक्वेशन वर्कआउट कर सकते हैं, या फिर एक और चीज है जिसको हम कर सकते हैं, हम ओरिजिन को शिफ्ट कर सकते हैं। तो हम ये जो x माइनस एच है इसको कैपिटल X मान लेते हैं और y माइनस के को कैपिटल Y मान लेते हैं। तो इक्वेशन को हम लिख सकते हैं कैपिटल X स्क्वायर प्लस कैपिटल Y स्क्वायर इक्वल्स आर स्क्वायर। अब ये तो वो सर्कल है जिसका सेंटर ओरिजिन पे है, तो यहाँ इसके लिए हम टेंजेंट का इक्वेशन लिख सकते हैं, और वो होगा कैपिटल Y इक्वल्स m टाइम्स कैपिटल X प्लस माइनस आर अंडर रूट 1 प्लस एम स्क्वायर। अब कैपिटल Y और कैपिटल X से वैल्यू पुट करते हैं, तो यहां से जो टेंजेंट का इक्वेशन आएगा वो आएगा आपका y माइनस के इक्वल्स m इंटू एक्स माइनस एच प्लस माइनस आर अंडर रूट 1 प्लस एम स्क्वायर। तो ये इक्वेशन को हम किसी भी जनरल सर्कल के लिए यूज कर सकते हैं। तो हमने देखा दूसरे मेथड में अगर एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल्स टू आर स्क्वायर है, तो इसके लिए टेंजेंट का इक्वेशन आएगा y इक्वल्स टू एम एक्स प्लस माइनस आर अंडर रूट 1 प्लस एम स्क्वायर। और अगर इक्वेशन है x माइनस एच स्क्वायर प्लस वाई माइनस के स्क्वायर इक्वल्स आर स्क्वायर, तो इक्वेशन हो जाएगा y की जगह y माइनस के, x की जगह x माइनस एच प्लस माइनस आर अंडर रूट 1 प्लस एम स्क्वायर। अगर एक सिंपल सा एग्जांपल ले लें, तो अगर सर्कल है एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल्स टू 4, तो इसका टेंजेंट हो जाएगा y इक्वल्स एम एक्स प्लस माइनस आर कितना 2 इंटू अंडर रूट ऑफ 1 प्लस एम स्क्वायर। और अगर सर्कल है x प्लस 2 स्क्वायर प्लस y माइनस 1 स्क्वायर इक्वल्स टू 4, तो यहाँ पे y की जगह y माइनस 1 और x की जगह x प्लस 2 प्लस माइनस आर अंडर रूट ऑफ 1 प्लस एम स्क्वायर। तो ये है आपका कंडीशन ऑफ टेंजेंसी और उसके साथ में इक्वेशन ऑफ टेंजेंट। और इक्वेशन ऑफ टेंजेंट लिखने का जो तीसरा तरीका है और सबसे आसान तरीका है वो है कि अगर पॉइंट सर्कल के ऊपर लाई करता है तो इक्वेशन ऑफ टेंजेंट जो है वो आएगा t इक्वल्स टू 0 से। तो यहां पे याद ये रखना है कि पॉइंट सर्कल पे लाई करता है। तो ये 3 तरीके हैं हमारे पास टेंजेंट निकालने के लिए, जिनको हम यूज करेंगे सवाल सॉल्व करने के लिए। अब आते हैं पैरामीट्रिक कोऑर्डिनेट्स एंड पैरामीट्रिक इक्वेशन ऑफ अ सर्कल। तो हम सबसे एलिमेंट्री सर्कल से शुरू करते हैं जिसका सेंटर ओरिजिन है। तो जैसे ये सर्कल का इक्वेशन है एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल्स आर स्क्वायर, जहां पे इसका रेडियस आर है। अब इस सर्कल के ऊपर कोई भी जनरल पॉइंट हम देखें, सपोज ये पॉइंट P है और ये एंगल अगर थीटा है तो OP कितना R, तो ये जो P का x कोऑर्डिनेट है ये हो जाएगा आपका R cos थीटा और इसका y कोऑर्डिनेट हो जाएगा आपका R sin थीटा। तो किसी भी पॉइंट को सर्कल के ऊपर हम मान सकते हैं कि ये पॉइंट है आपका R cos थीटा R sin थीटा और ये है आपका पैरामीट्रिक कोऑर्डिनेट। और अगर हम ये इक्वेशन को ऐसे लिखें कि x इक्वल्स R cos थीटा और y इक्वल्स R sin थीटा, तो इसमें अगर थीटा को एलिमिनेट करेंगे तो एक्स स्क्वायर प्लस वाई स्क्वायर इक्वल्स आर स्क्वायर मिल जाएगा। तो ये जो इक्वेशन आएगा इसको हम बोलते हैं ये आपका पैरामीट्रिक इक्वेशन। तो एक सिंपल सर्कल जिसका सेंटर ओरिजिन पे है और जिसका इक्वेशन x स्क्वायर प्लस वाई स्क्वायर इक्वल्स आर स्क्वायर है, उस सर्कल पे एक पॉइंट को हम मान सकते हैं, वो है r cos थीटा r sin थीटा। लेकिन हर सर्कल का सेंटर ओरिजिन पे नहीं होता है। तो अगर हम एक दूसरा सर्कल कंसीडर करें कि जैसे x माइनस एच स्क्वायर प्लस वाई माइनस के स्क्वायर इक्वल्स आर स्क्वायर, तो इस सर्कल के लिए अब जो सेंटर है वो है आपका h कॉमा के। तो अगर यहां पे कोई पॉइंट देखें ये P और ये एंगल थीटा है, तो यहां पे इसका जो x कोऑर्डिनेट आ जाएगा वो आ जाएगा आपका h प्लस आर कॉस थीटा और y कोऑर्डिनेट हो जाएगा आपका k प्लस आर साइन थीटा। तो एक जनरल सर्कल के लिए जिसका सेंटर h के है, रेडियस r है, तो उसका पैरामीट्रिक कोऑर्डिनेट है h प्लस आर कॉस थीटा कॉमा के प्लस आर साइन थीटा, और उसका जो पैरामीट्रिक इक्वेशन है वो है x इक्वल्स h प्लस आर कॉस थीटा और y इक्वल्स के प्लस आर साइन थीटा। अब एक एग्जांपल अगर ले लें, एक सर्कल है जो है x माइनस थ्री स्क्वायर प्लस वाई प्लस वन होल स्क्वायर इक्वल्स टू स्क्वायर। अब इस सर्कल पे एक पॉइंट चाहिए पैरामीट्रिक कोऑर्डिनेट के टर्म्स में, तो पैरामीटर थीटा है। अब यहां पे h है आपका 3, k है आपका -1 और r है आपका 2। तो इस सर्कल के ऊपर कोई भी जनरल पॉइंट हम मान सकते हैं h प्लस आर कॉस थीटा, सो विल बी 3 प्लस 2 कॉस थीटा कॉमा k प्लस आर साइन थीटा। तो ये हो गया -1 प्लस 2 साइन थीटा। तो इस तरीके से हम एक सर्कल के लिए पैरामीट्रिक कोऑर्डिनेट्स और पैरामीट्रिक इक्वेशन डिफाइन कर सकते हैं। तो कुछ क्वेश्चंस होंगे जहां पे हम सर्कल के ऊपर एक पॉइंट को पैरामीटर थीटा के टर्म्स में डिफाइन करेंगे, और यहाँ पे जो थीटा है वो थीटा का वैल्यू लाई करता है 0 से 2 पाई के बीच में। कि आप थीटा को 0 से 2 पाई के बीच में रोटेट करेंगे तो आपको ये सर्कल के ऊपर सारे पॉइंट्स मिल जाएंगे। Now the question is, show that the equation of a straight line meeting this circle in 2 points at equal distances d from the point x1 y1 on its circumference is x x1 plus y y1 minus a square plus d square by 2. So we have this circle whose center is at origin and radius is a, and we have this straight line which meets the circle at 2 points, say A and B, at equal distance d from point x1 y1. So we have this point, say P, which is x1 y1 and it is at an equal distance. So this is an isosceles triangle. Now we draw a perpendicular. This is 90. And this is also isosceles. So origin will have this perpendicular. Now basically this line will be parallel to tangent at this point P. And we know that equation of tangent at this point P is given by P equals 0, which is simply x x1 plus y y1 minus a square equals 0. Now a line parallel to this given line will be given by x x1 plus y y1 plus lambda equals 0. Now we need to find the value of lambda. Now this angle is theta, this angle will be 2 theta. Now this distance AC, it can be written as this d sine theta, and it can also be expressed as this a sine 2 theta. Now sine 2 theta is 2 sine theta into cos theta. Now sine theta will cancel, so from here we can write cos theta as d upon 2a. So this perpendicular distance PC, it will be d cos theta, which is simply d square by 2a. Now we'll have two things to consider. First, this line, it should be a chord, and it will be chord if perpendicular distance from origin it is less than its radius. So that means this mod of lambda upon under root of x square plus y square will be less than a. This is x1 square plus y1 square, which is a. So basically mod of lambda should be less than a square, and then perpendicular distance from P, it should be equal to this d square by 2a. So it will be this x1 square plus y1 square plus lambda upon under root of x1 square plus y1 square mod will be equal to d square by 2a. Now this is a and a will cancel. This is a square. So value of lambda is plus minus d square by 2 minus a square. So either the value of lambda is d square by 2 minus a square, or it is minus d square by 2 and minus a square. Now in this case, this mod of lambda, it won't be less than a square. So we are going to discard this case. So the value of lambda we'll get is lambda equals d square by 2 minus a square. So equation of this line will be x1 plus y1 plus lambda, which is d square by 2 minus a square equals 0, which is what we need to prove in this question. Now the question is, if these are the 4 distinct points on a circle of radius 4 units, then ABCD is equal to which of the following? Now we can see all the 4 points, they lie on this rectangular hyperbola xy equals 1. So we have this rectangular hyperbola, and it says there is a circle which intersects these rectangular hyperbola at 4 points. So its equation will be x square plus y square equals 16. Now if we look at these 4 points of intersection, we'll need a biquadratic equation. So what we'll do is we'll replace the value of y here. Y is 1 by x. We'll get x square plus 1 upon x square. It is equal to 16, or x to the power 4 minus 16x square plus 1 equals to 0. Now this equation will have 4 real roots, a, b, c, d. Now product of roots a, b, c, d will be equal to this 1 upon 1, and that's your option C. Now here the question is 3 concentric circles, of which biggest is x square plus y square equals 1. So we have 3 concentric circles. Center at origin, and radius of this bigger circle is 1, and have their radius in AP. So suppose this is 1, radius for this is suppose 1 minus d, and radius for this circle is 1 minus 2d, where d is greater than 0. It says if the line y equals x plus 1 cuts all the circle in real and distinct points, the interval in which common difference of AP will lie is. Now a line is going to intersect the 3 circles if it intersects this smaller circle. So perpendicular distance from the center must be less than its radius. Now perpendicular distance from the center to this line will be 0 minus 0 plus 1 upon root 2. It should be less than 1 minus 2d, or we'll write 2d is less than 1 minus 1 by root 2, or d is less than root 2 minus 1 upon 2 root 2. We can also write this as 2 minus root 2 upon 4. Now this common difference, it should be greater than 0, and it should be less than this value. So this d, it belongs to the interval 0 comma 2 minus root 2 upon 4, and that's your option C. Now here the question is, a circle is drawn with its center on the line x plus y equals 2 to touch this line 4x minus 3y plus 4 equals 0 and pass through the point 0 comma 1. Find its equation. Now let the center be h comma k, and since the center it lies on this line, we can write h plus k equals 2, or simply k equals 2 minus h. So we write this center as h comma to minus h. Now this circle, it touches this line, and we know that condition of tangency is perpendicular distance from the center must be equal to its radius. So if we write perpendicular distance from the center to this line, it'll be this 4h minus 3 into 2 minus h plus 4 upon under root of 4 square plus 3 square, and it'll be equal to its radius. And we can write this radius in terms of this distance of center from this point on the circle. So it'll be this under root of h square plus, now 2 minus h minus 1 will be 1 minus h whole square. Now this is simply 7h minus 2, and it will be equal to this 5 into under root of 2h square minus 2h plus 1. Now we square it, we can write this as 49h square plus 4 minus 28h, and that will be 25 into 2, 50. So it is 50h square minus 50h plus 25. Now it will be this h square. Now minus 50 plus 28. That will be minus 22h plus 21 equals 0. So we can factorize this as h minus 1 into h minus 21 equals 0. So value of h is either 1 or it is 21. Now once we have this h, we can write center of this circle. Now center of this circle will be h comma 2 minus h. So if h is 1, it will be 1 comma 1, or when h is 21, it will be 2 minus 21, which is minus 19. And we can also write its radius. Now this r is under root of h square plus 1 minus h whole square. Now if h is 1, then this radius is 1, and if h is 21, it will be this 21 square plus 20 square, which is under root of 841. Now once we have center and radius, we can write equation of this circle. So equation of this circle will be either x minus 1 square plus y minus 1 whole square, it is equal to 1, or it will be x minus 21 square plus y plus 19 whole square, and that will be equal to 841. And this is the answer to this question. Now here the question is, a point moving around this circle with center at minus 4, minus 2 and radius 5 broke away from it either at the point A or point B on the circle and moved along a tangent to the circle, passing through the point this D 3, minus 3. Now we know that a moving point on a circle will go along its tangent, and since it says if it either goes from A or from B, it goes through the same point D. That means we are talking about pair of tangents drawn to this circle from this point D. So we have this circle with center at minus 4, minus 2, and then we have drawn two tangents at these points A and B, and these tangents, they pass through this point D, which is 3, minus 3. Center is at minus 4, minus 2. And that's your radius, which is 5 units. Now the first question is, find the equation of tangents at A and B. Now what we'll do is, we'll write equation of tangent to this circle in terms of slope of tangent. So we can write this as y plus 2 equals m, and x is x plus 4 plus minus r, and r in this case is 5 under root of 1 plus m square. Now here we are looking for the tangents which pass through the point D 3, minus 3. So we'll put y as minus 3 and x as plus 3. So now it'll be this minus 1, and then this is 7m plus 5 under root of 1 plus m square. We can also write this as plus minus 5 under root of 1 plus m square, and it will be equal to minus 1 minus 7m. Now we square it, we can write 25 plus 25m square, and it will be equal to 1 plus 49m square plus 14m. Now 49m square minus 25m square is 24, so that will be 24m square plus 14m minus 24 equals 0, or 12m square plus 7m minus 12 equals 0. Now we can write this as 12m square plus 16m minus 9m minus 12 equals 0, or it will be this 4m, and there will be 3m plus 4, and then minus 3, and this is 3m plus 4 equals 0. So value of m will be either 3 by 4 or value of m is minus 4 by 3. And as we can see, product of slope is minus 1. That means this angle, it is 90 degrees. Now once we have m and we have this point, we can write equation of these tangents. So one of the equation will be y plus 3 equals 3 by 4 x minus 3, which is 3x minus 4y, and this is 12 minus 9 minus 21 equals 0, and the other one will be y plus 3 equals minus 4 by 3 x minus 3, which is 4x plus 3y minus 3 equals 0. So these are the equation of two tangents. Now the second question is, find the coordinates of the points A and B. Now once we have equation of tangents and we know the center, which is minus 4 comma minus 2, we know that these point of contacts are basically foot of perpendicular. So we'll use this foot of perpendicular formula to find the coordinates of these points A and B. So for this second part, first we're going to start with this line, which is 3x minus 4y minus 21 equals 0, and we'll find foot of perpendicular from center, which is minus 4 minus 2. Now this is x plus 4 upon 3, y plus 2 upon minus 4, and will be this minus, and then this is minus 12 plus 8 minus 21 upon 3 square plus 4 square. So it will be this x plus 4 upon 3, y plus 2 upon minus 4, and here this is 25 upon 25, which is 1. Now value of x is minus 1, and this is minus 6. So one of the point of contacts, say this point A, it is minus 1 minus 6. And now we'll take this other equation, which is 4x plus 3y minus 3 equals 0, and now we'll find foot of perpendicular from center. So it will be this x plus 4 upon 4 equals y plus 2 upon 3, and it will be equal to this minus, and this is minus 16 minus 6 minus 3 upon 3 square plus 4 square, which again is 1. Now in this case, value of x is 0 and value of y is 1. So this other point is 0 comma 1. So coordinate of these points of contact, there are minus 1 comma minus 6 and 0 comma 1. Now this third question is, we need to find this angle ADB and the minimum and maximum distance of D from the circle. Now as we have already seen that this slope is 3 by 4 and this slope is minus 4 by 3. Product of slope is minus 1. So basically this angle, it is 90 degrees. So we can simply write angle ADB, it is 90 degrees. And now we have to find minimum and maximum distance of this point D from this circle. Now what we'll do is we'll find distance of this point from center. So it will be the CD. So we'll write CD and that'll be equal to under root of, now this is 3 minus of minus 4, 7. So it will be this 7 square plus, and this is minus 3 plus 2, 1, which is under root 50, and under root 50 is 5 root 2. Now this point, it is nearest to D, and this other end of diameter will be this farthest point. So this minimum distance will be simply CD minus this radius R. So it will be this 5 root 2 minus 5, and this maximum distance will be this CD plus R, and which is 5 root 2 plus 5. So this is how we find minimum and maximum distance of a point from a circle. Now it says we need to find area of quadrilateral ADBC and area of this triangle DAB. Now we already know that this angle is 90 degrees. So this is 45 degrees. And if it is 45, then this AD is 5. And this distance, it is 5 sine 45. So it will be this 5 by root 2 and 5 by root 2. Now first we'll write area of this quadrilateral ADBC. Now this is R into delta S. So basically it will be this AC into AD. Now AC is 5 and AD is also 5. So this area is 25. And we can also write area of this triangle ABD. Now this is half and then AB. Now AB is 2 times 5 by root 2 into this perpendicular distance, and it will also be 5 by root 2. Now this 2 and 2 will cancel. So this is 25 by 2, which is 12.5. So area of this triangle DAB is 12.5 square units. Now finally the fifth part, equation of circle circumscribing this triangle DAB. So equation of circumcircle of this triangle DAB. Now basically this is a standard result. Circumcircle of this triangle DAB will pass through center of the circle. So basically CD is a diameter, and if CD is a diameter, then center of this new circle, say C dash, will be midpoint of CD. So this C dash will be minus 4 plus 3 upon 2. So that is minus 1 by 2. And here it is minus 2 minus 3 upon 2, which is minus 5 by 2. And its radius will be half the distance CD. And we know that this CD is 5 root 2. So its radius will be 5 by root 2. So equation of this circle will be x plus 1 by 2 square plus y plus 5 by 2 square, and that will be equal to 25 by 2. Now we can write this equation as x square plus x plus 1 by 4 plus y square plus 5y plus 25 by 4, and that will be equal to 25 by 2. Now 25 by 2 minus 25 by 4 is 25 by 4, and minus 1 by 4, that will be 24 by 4, and 24 by 4 is 6. So this equation will be x square plus y square plus x plus 5y minus 6 equals 0. And also we have to find intercept made by this circle on coordinate axis. Now we know that x-axis intercept is 2 times under root g square minus c, and y-axis intercept is twice under root f square minus c. Now this is 2 under root of, now what is g square? Now g in this case is 1 by 2, so there will be 1 by 4 plus 6. Now this is 25 by 4, so it will be simply 5. So value of x-axis intercept is 5, and value of y-axis intercept will be 2 into under root of, now f is 5 by 2, so there will be 25 by 4 plus 6. Now this is 25 plus 24, 49, 7 by 2, so it is 7. So length of x-axis intercept is 5 and length of y-axis intercept is simply 7. And that is the answer to this question. Now here the question is, consider a circle S with center at the origin and radius 4. 4 circles A, B, C, D, each with the radius unity and centers -3, 0, -1, 0, 1, 0 and 3, 0 are drawn. A chord PQ of the circle S, it touches the circle B and passes through center of circle C. If the length of this chord can be expressed as under root x, find x. So basically first we have the two axes, x-axis and y-axis, and then we have this circle S with center at origin and radius 4. And then we have these 4 smaller circles, each of radius 1 unit. So that's your origin, and this point is 4, 0. This is -4, 0, and these centers are at -3, -1, 1 and 3. Now suppose this is A, B, C and D. Now it says there is a chord PQ of the circle S which touches this circle B and passes through center of this circle C. So we have this chord PQ which touches the circle B and passes through center of this circle C, and this center is 1, 0. We have to find length of this chord PQ. Now we'll drop a perpendicular from center. This is 90. Radius of this circle is 1 unit. This distance is 2 units, and let this angle be theta. Then we can simply write sine theta as 1/2, or simply theta is pi/6. So basically tan theta will be 1/√3, and slope of this line will be tan pi minus theta, and tan pi minus theta is minus tan theta. So slope of this line is -1/√3. So once we have slope and this point, we can write equation of this line as y minus 0 equals -1/√3 x minus 1, or simply we can write x plus √3y, it is equal to 1. So equation of PQ is x plus √3y minus 1 equals 0. Now we'll find perpendicular distance from center of the circle S. So this perpendicular distance will be 0 plus 0 minus 1 upon under root of 1 plus √3 square, which is 1/2. So this is say R. So value of OR, it is 1/2, and OP is radius of this circle, which is 4. So we can find PR as under root of OP square minus OR square, and which is under root of 16 minus 1/4. Now this is 64. 64 minus 1 is 63, which is 3√7/2. And PQ is basically 2 times PR, which is simply 3/√7, or we can simply write this as under root of 63. So we have expressed it as under root x. So basically value of x here is 63. Now the question is, a circle with center in the first quadrant is tangent to this line y equals x plus 10 and y equals x minus 6 and the y-axis. So we have coordinate axis, and then we have two parallel lines, and then it says we have this circle whose center is in the first quadrant and which touches these two straight lines and y-axis. Now suppose center of this circle B hk. Now we know that since this circle, it touches y-axis, its radius will be equal to modulus value of its x coordinate. So equation of this circle will be x minus h square plus y minus k square, and it will be equal to h square. Now we find distance between these two lines. Distance between these two parallel lines will be given by 16 upon root 2, basically, which is 8 root 2, and this 8 root 2 will be equal to 2r, and r we know is mod h. So it will be this 2 mod h. So value of h is 4 root 2. Now we will find k. So this h, it is also its radius, which is 4 root 2. So perpendicular distance from center of the circle, it must be equal to its radius for this line, and this line is x minus y minus 6 equals 0. So we can write this as mod of h minus k minus 6 upon root 2. It should be equal to 4 root 2. Now h is 4 root 2, so we can write k plus 6 minus 4 root 2 will be equal to 8, or k plus 6 minus 4 root 2, it is equal to plus or minus 8. So if we take this plus sign, we'll get this k as 2 plus 4 root 2, and if we take this minus sign, we'll get this k as minus 14 plus 4 root 2. And since this center, it lies in first quadrant, k has to be positive, so we'll accept this value of k. So value of k is 2 plus 4 root 2. Now it says we have to find the value of h plus k. So value of h plus k will be 4 root 2 plus 2 plus 4 root 2, which is 2 plus 8 root 2. Now they've expressed it as a plus b into under root a. So in this case, value of a is 2 and value of b is 8. Now we have to find value of a plus b. A plus b is simply 2 plus 8, 10, and that is the answer to this question. Now it says a circle is described to pass through the origin and to touch these lines x equals 1 and x plus y equals 2. Prove that the radius of the circle is root of this equation. So we have these two lines, x equal to 1 and then x plus y equals 2, and this circle, it touches these two lines and it passes through origin. So it will be in this circle. Let the equation be x square plus y square plus 2gx plus 2fy equals 0, since it passes through origin. So value of c must be 0. And center will be at minus g minus f, and its radius will be under root of g square plus f square. So this point is minus g minus f. And if we look at this distance will be mod of 1 plus g, and it will be equal to r, and perpendicular distance to this line also will be equal to r. So perpendicular distance to this other line will be minus g minus f minus 2 upon root 2. It is equal to r, or mod of g plus f plus 2, it is equal to root 2r. Now basically we have to decide about these mod signs. Now clearly this point, it lies on the left of x minus 1. So 1 plus g will be greater than 0. So from here we can write simply 1 plus g, it is equal to r. And if we look at this line, then we put origin, so 0 minus 2 it is minus 2 less than 0. And if we put minus g minus f, so it will be this minus g minus f minus 2 will also be less than 0 as they lie on the same side. So from here we can write g plus f plus 2 will be greater than 0. So from here we get g plus f plus 2 will be equal to root 2r. So from here we can say value of g is r minus 1, and if we put r minus 1 here, we'll get f as root 2 minus 1 into r minus 1. Now we'll put the value of g and f in this equation. So now we can write r square will be equal to g square, and g square is r minus 1 whole square plus f square, which is root 2 minus 1 r minus 1 whole square. When we square it, we can write r square equals r square plus 1 minus 2r, and here will be this root 2 minus 1 whole square into r square plus 1 minus 2 root 2 minus 1 into r. Now here r square and r square will cancel. We can write this as root 2 plus 1 whole square. So there will be 3 minus 2 root 2 r square, and then it will be minus 2 root 2r, minus 2r and plus 2r will cancel. There will be minus 2 root 2r and then plus 2 equals 0. So radius of this circle will be given by this quadratic equation, which is basically the same equation, 3 minus 2 root 2 t square minus 2 root 2 t plus 2 equals 0, which is what we need to prove in this question. Now here the question is, a circle is tangent to the x and y axis in the first quadrant at the points P and Q. BC and AD are parallel tangents to the circle with slope minus 1 if the points A and B are on the y-axis while C and D are on the x-axis, and the area of figure ABCD is 900 root 2 square unit, then find the radius of this circle. We'll draw this circle. Now this circle, it touches both the axes at points P and Q. So this is P and this is Q, and suppose radius is R. So center of this circle will be at R comma R. Now it says there are two parallel lines with slope minus 1 which touches this circle. So we have two lines which are parallel and whose slope is minus 1, where the points A and B are on y-axis and C and D are on x-axis. So this is A, this is B, this is C, and this is D. And area of ABCD is 900 root 2. Now since slope is minus 1, this point is suppose A comma 0. So this point will be 0 comma A, and this is B comma 0, and here will be this 0 comma B. Equation of this line will be x plus y equals A, and this is x plus y equals B. Now this line, it lies in the middle of these two lines. So this line will be given by x plus y equals A plus B by 2, and center of this circle will lie on this line. So from here we can write this R, it must be equal to A plus B by 4. So we have this R, which is A plus B by 4. Now we can write area of this quadrilateral ABCD. Now this AD is root 2A and this BC is root 2B. So this area will be 1 by 2 and then root 2A plus root 2B into this perpendicular distance, which is nothing but 2R, and it is equal to 900 root 2. Now we can take root 2 common, so it will be this root 2 and this 2 and 2 will cancel, and we have A plus B. Now A plus B is nothing but 4R, so it will be this 4R into R, and there will be 900 root 2. Now this is 100 and this is 225. So value of r is basically 15. So radius of this circle is 15 units. Now in this question, we are given 3 columns and then we have to answer the 3 questions. We know that column 1, column 2 and column 3 are obviously related. So we are going to join these columns. Now this is parabola y is equal to 4ax. Now its tangent is y is equal to mx plus a by m. So this third, it is connected with 1 and point of contact is 80 square 280. It will be this 3 1p. Now x square upon a square plus y square equals to 1. This is ellipse and equation of ellipse is given by y is equal to mx plus minus under root a square m square plus b square. So that means the second, it matches with 4 and its point of contact will be this r. For this circle, equation of tangent is y is equal to mx plus minus r under root 1 plus m square and the point on the circle is minus maa. So this first, it matches with second, it matches with q, and this hyperbola, it matches with third and it matches with s. So these are the possible combination for the 4 given curves. Now this first question is the tangent to a suitable conic at this point, say a, root 3 comma 1 by 2, it is root 3x plus 2y equals to 4. So here we have this conic and tangent at root 3 comma 1 by 2 will be drawn like this. Now for parabola and hyperbola, tangent will have positive slope. So it cannot be a parabola or a hyperbola. So it can only be a circle or an ellipse. But in case of a circle, equation of tangent will be x(x1) plus y(y1) equals a square, where point of contact is x1, y1. So in that case, this equation will be root 3x plus 1 by 2y. So it cannot be this circle. So it has to be this ellipse. So this point, it should lie on ellipse. So answer should be second, fourth, and R. That's your option D. Now we'll prove it also. Now if we have this point will lie on this ellipse. So we'll get 3 plus a square by 4 equals a square. So value of a square is 4. That means value of a is 2. So equation of this ellipse will be x square plus 4y square equals to 4. Now equation of tangent is given by t equals 0. So there will be root 3x plus 4 into 1 by 2y equals 4. So it will be this root 3x plus 2y equals 4, which is this given option. Now we have to verify this point of contact. This minus a square m. So this is minus 4m is minus root 3 by 2 upon under root of a square m square plus 1. And this is a square m square plus 1. Now this is root 3 comma 1 by 2. So that means this one, it matches with D. Now the second one is, if tangent to a suitable conic is found to be y equals x plus 8 and the point of contact is 8 comma 16, then which of the following option is the correct combination? Now in this case, it has to be either this parabola or this hyperbola. So for this second question, we know that this point is 8 comma 16 and it is y equals x plus 8. Now in this case, value of m is 1 and this parabola is y square equals 4ax. So first we'll check for this parabola. Now this is 16 square and this is 16 into 2. So value of a is 8. And we know that equation of tangent is given by y equals mx plus a by m. That means this is the equation of tangent. And point of contact, it is given by a upon m square and 2a upon m. So it will be this 8 comma 16, which is this given condition. So it will be this parabola. Third, it connects with 1 and p. So it will be 3 1p. And that's your option A. And the next one is, for a equals root 2, if a tangent is drawn to a suitable conic at the point of contact minus 1 comma 1, then which of the following option is the only correct combination for obtaining its equation? Now if we put x as 1 and y as 1, then we should get a as root 2. This is only possible in this case of a circle. So this third one, it should be this 1, 2 and q. And that's your option D. Now in this case, since a is root 2, equation of this circle is x square plus y square is equal to 2. Point of contact is minus 1 comma 1. Equation of this line is x plus y equals to 2 and value of m is 1. And if we put a as root 2 and m as 1, so here root 2 will cancel. So this is minus 1 comma 1, which is a given point. So the correct options are D, A, D. Now here the questions, we are given two lines L1 and L2 and they are parallel to each other. So we have two lines. One of the line is 2x plus 3y plus p minus 3 equals 0, and the other one is 2x plus 3y plus p minus 3 equals 0. And we have this circle which is x square plus y square plus 6x plus 10y plus 30 equals 0. If it is given that at least one of the line is a chord of the circle C, then the probability that both are chords of C is. Now first we have to find the condition that at least one of the line is a chord of C. Now center of the circle, it is at minus 3 comma minus 5 and its radius is under root of 9 plus 25 minus 30 and which is 2. Now first we'll take this condition that 2x plus 3y plus p minus 3 equals to 0 is a chord of a circle. Now it'll be chord of the circle if perpendicular distance from the center is less than r. So then perpendicular distance from the center will be this minus 6 minus 15 plus p minus 3 upon, now this is under root 9 plus 14, 13. So there will be under root 13 and it should be less than 2. So we'll get this condition that mod of p minus 24, it is less than 2 root 13, or this p, it lies between 24 minus 2 root 13 to 24 plus 2 root 13. Now for the second one, the only difference is we'll have p plus 3 here, and if we have p plus 3 here, we'll get this as p minus 18. So the second condition is if this line 2x plus 3y plus p plus 3 equals to 0 is a chord of this circle, then we'll get mod of p minus 18 will be less than 2 root 13. So basically the condition will be p should lie between 18 minus 2 root 13 to 18 plus 2 root 13. Now we draw all these solutions on a number line. Then first we have 18 minus 2 root 13. And then there will be this 18 plus 2 root 13. And the second line will be chord of this circle if value of p lies between these two values. And next we have this 24 minus 2 root 13. Now root 13 is 3 point something. So this is 6 point something. 24 minus 6 point something is 17 point something, which is going to be here. So this point 24 minus 2 root 13 and 24 plus 2 root 13 will be here, and this second line will be chord of this circle if it lies between these two values. Now we need to find this probability that both of them, they are chord of the circle when it is given that at least one of them is chord of the circle. Now it says p can only take integral values, so we have to work these values out. Nearly 25.2 and this value is nearly 31.2 and this value is nearly 10.8 and this is nearly 16.8. Now the integral values of p in this set S1, they are 11, 12 up to 25. So the values of P for which this first line, it is a chord of the circle, is this set S1 from 11 to 25, and the set that the second line is a chord of the circle LB from 17 to 31. Now intersection of S1 and S2 is values where both the lines, they are chord of the circle, and these values, they'll start from 17 up to 25. So there are 9 values, and S1 union S2 will be values from 11 to 31, and here we have 21 values. So this required probability will be variable values 9 upon total values 21, which is 3 by 7, and that's your option B. Now here the question is, common tangents to the circle x square plus y square equals 2, and this parabola y square equals 8x, they touch the circle at P and Q and parabola at R and S. So these tangents, they touch the circle at points P and Q and parabola at R and S, and it says find the area of this quadrilateral PQ RS. Now we can write equation of tangent to this circle, and it is given by y equals mx plus minus r under root 1 plus m square, and for this parabola it is given by y equals mx plus a by m, and a in this case is 2, so it will be this 2 by m, and we are talking about common tangent, so it will have same slope and same equation. So from here we can write plus minus root 2 under root 1 plus m square will be equal to 2 by m, so it will be this root 2, and we square it, we can write m to the power 4 plus m square minus 2 equals 0, or m square plus 2 into m square minus 1 equals to 0. So value of m is plus or minus 1. So equation of one of the line is y equals x plus 2, and equation of this other tangent is y equals minus x minus 2. Now we have to find this point of contacts P and Q. Now suppose this P is x1 y1, then equation of tangent to this circle will be given by x1 plus y1 minus 2 equals 0, and we'll compare it with this x minus y plus 2 equals 0. So from here we get x1 upon 1 y1 upon minus 1, it is equal to minus 1. So this point of contact is at minus 1 comma 1. So this P is minus 1 comma 1, and this Q is minus 1 comma minus 1. For this parabola, we know that point of contact, it is given by a by m square and 2a by m. Now in this case, a is 2 and m is 1, so it will be this 2 comma 4. So coordinate of R is 2 comma 4, and this coordinate will be 2 comma minus 4. Now we have to find area of this trapezium. Now area of this trapezium, it is given by 1 by 2 sum of parallel sides. Now this is 2 and this is 8, so there will be 10 into this perpendicular, and this perpendicular is simply 3. So this area is 15 square units. So the correct option is this option D. Now here the question is, if O is origin and OP and OQ are distinct tangents to this circle. So we have this circle whose center is at minus G minus F, and then we have drawn tangents from origin for which contact points are P and Q. That says circumcircle of triangle OPQ. Now it's a standard result that circumcircle of triangle OPQ will pass through center of this given circle, and basically center of the circle will be midpoint of OC. So we are looking for this point. Now this point is midpoint of OC, and midpoint of OC is minus G by 2 and minus F by 2, which is none of these. And that's your option D. Now the question is, if the normals to the parabola drawn at the end points of its latest rectum are tangent to this circle, then the value of R square is. Now we know that equation of normal to parabola, it is given by y equals mx minus am cube minus 2am. Now in this case, value of a is 1, and at end points of latest rectum, value of t is plus minus 1, and m is 1 upon t. So this m will also be plus or minus 1. So we'll take m as 1 and a as 1. So equation of this line will be x minus y minus 3 equals 0. Now this line, it is tangent to this circle whose center is at 3, minus 2, and radius is r. So we'll get 3 plus 2 minus 3 upon root 2, and this will be equal to r. So value of r square will be simply 2. So answer to this question is 2. Now the question is, a circle with center at origin intersects the parabola x square is equal to 2y at the point P in the first quadrant. Let the tangent to the circle C1 at P touches the other two circles C2 and C3 at R2 and R3 respectively. Suppose C2 and C3 have equal radius 2 root 3 and centers Q2 and Q3 respectively. If Q2 and Q3 lie on y-axis, then we have to find which of the following options are correct. So here we have this circle which is x square plus y square equals 3, and it intersects this parabola x square equals to 2y at this point P. So what we'll do is we'll first find coordinate of this point P. So it will be this y square plus 2y minus 3 equals 0. So it will be this y plus 3, y minus 1 equals 0. So from here we get y equals to 1 because this point, it is in the first quadrant, and if we put y as 1, we'll get x as root 2. So this point P is root 2, 1. Now we'll draw tangent to this circle C1 at this point P, and it will be given by root 2x plus y, and it is equal to 3. So that is the equation of this tangent. Now it says it touches two circles C2 and C3 whose radius is 2 root 3 and they lie on y-axis. So suppose we have two circles, say Q2 and Q3, their radius are equal, and this tangent, it touches two circles at points R2 and R3. Now suppose center of Q2 and Q3, it is given by 0, k, then perpendicular distance from the center must be equal to its radius. So from here we can write 0 plus k minus 3 upon root 3 will be equal to 2 root 3, or k minus 3, it is equal to plus or minus 6. Now if we take minus sign, we'll get k as minus 3, and if we take plus sign, we'll get k as 9. So this Q2 is 0, 9, and Q3 is 0, minus 3. So we have Q2 as 0, 9 and Q3 as 0, minus 3. We can write Q1, Q2, and Q1, Q2 is 12. That means this option A, it is correct. And in this case, this line will not pass through origin. So suppose this is your x-axis. Now we'll find coordinate of this point where this line, it intersects y-axis. For y-axis, we'll put x as 0. So this point will be 0, 3. Now this is 90. And this is also 90. This is 6. This is 2 root 3. So basically this point, say A, R2A, it will be this distance 6. 6 square is 36 minus, now 2 root 3 square will be 12. So it will be root 24, which is 2 root 6. And this distance also will be 2 root 6. So both the distances, they are 2 root 6. So distance between R1, R2 will be simply 4 root 6. That means this option B is also correct. Now this C is area of triangle O, R2, R3. Now we already have base. So R2, R3 is 4 root 6. Now we can find perpendicular distance D, and there will be perpendicular distance from origin to this line. So there will be this 3 by root 3, and there will be simply under root 3. So area of this triangle will be half base is 4 root 6 into altitude, which is 3. So this is 2. So it will be simply 6 root 2. That means this option C is also correct. And option D is area of triangle PQ2, Q3. Now Q2, Q3 is 12. Coordinate of this point P is root 2, 1, and perpendicular distance from y-axis, it is equal to x coordinate. So perpendicular is root 2. So area of this triangle will be 1 by 2 base into altitude, and there will be 6 root 2 square units. That means this option D is incorrect. So the correct options are A, B and C. Now here the question is, a line meets the coordinate axis in A and B. A circle is circumscribed above this triangle OAB if M and N are the distance of the tangents to the circle at the origin from the points A and B respectively, then diameter of circle is. So here we have coordinate axis X and Y, and then we have this line which meets the coordinate axis in A and B. So we have these points A and B, and suppose A is A, 0 and B is 0, B, and here this angle, it is 90 degrees. Now it says we draw a circle circumscribing this triangle OAB. So we have this circle circumscribing this triangle OAB. Now it says we have drawn a tangent at O, and length of perpendicular from tangent to these points A and B, they are M and N. So this is M and this is N. We have to find diameter of the circle. Now we know that equation of this circle will be given by x minus a into x plus y into y minus b equals 0. So it will be this x square plus y square minus ax minus by equals 0. Now we can find equation of tangent to this circle at x equal to 0 through t equals 0. Now this is 0x plus 0y will be this minus a x plus 0 upon 2 and minus b y plus 0 upon 2. So equation of this tangent is given by ax plus by equals 0. Now we find length of perpendicular from A will be this m, and then will be this a square upon under root of a square plus b square, and the same way if we find n will be b square upon under root of a square plus b square. Now diameter of the circle is AB, which is simply under root of a square plus b square. So what we'll do is we'll add these two. So if we add these two, we'll get m plus n equals a square plus b square upon under root of a square plus b square, which is simply under root of a square plus b square, which is AB, diameter of the circle. So answer to this question is this option B. Now the question is, tangents are drawn from a point P to this circle whose center is at 3, 2, and this point P, it is at 1, 8. Now circumcircle of this triangle PAB, we know that it will pass through C. So this is A, this is B, and this point is C. And this PC, it is going to be diameter of this circumcircle. So center of this circle says C dash, it is midpoint of PC, and midpoint of PC is 2, 5, and its radius is distance of center from P. So it will be this under root of 1 plus 3 square, and there will be under root 10. So equation of this circumcircle will be x minus 2 square plus y minus 5 whole square, and will be equal to 10, or we can write x square plus y square minus 4x minus 10y plus 19 equals 0, and that's your option B. Now here the question is, lines 5x plus 12y minus 10 equals to 0 and 5x minus 12y minus 40 equals to 0 touch a circle C1 of diameter 6. If the center of C1 lie in the first quadrant, find the equation of circle C2, which is concentric with C1 and cuts an intercept of length 8 on these lines. Now what we'll do is, first we'll draw these two lines roughly on coordinate plane. So this first line is 5x plus 12y plus 10 equals to 0. So here x-axis intercept is 2 and y-axis intercept is little less than 1. So it will be this line. So this is 5x plus 12y minus 10 equals 0. Now for the second line, x-axis intercept, it is at 8, 0, and y-axis intercept is at 3 point something, but in the negative axis. So this line will be drawn something like this. Now slope of this first line, it is minus 5 by 12, and slope of the second line, it is 5 by 12. So basically these two lines, they'll make these equal angles. Now a circle whose center is in the first quadrant and which touches both the lines will have its center along this angle bisector. And for this, we have to find x coordinate of their point of intersection. So if we add them, we'll get this as 10x minus 50 equals 0. So this line is x equal to 5 line. So center of this circle will lie at 5, k. Radius of the circle is 3 units. So this is 3 units. Now perpendicular distance from the center must be equal to its radius. So we'll get 25 plus 12k minus 10 upon 13, and it will be equal to 3. So we'll get this as 12k plus 15, it is equal to 3 into 13, or 4k plus 5 equals plus or minus 13. Now we need the center in the first quadrant, so we'll take plus sign. So we'll get 4k equals 8. So value of k is 2. So center of this circle, it is at 5, 2. So this center, it is at 5, 2. That says we have to find equation of the circle C2, which is concentric with C1. So that means for this circle C2, center is again at 5, 2. Now this C2, it cuts an intercept of length 8 on these lines. So this C2, it cuts an intercept of 8 units on each of these lines. So we'll take this one line, 5x plus 12y minus 10 equals 0. This is 5 by 2. Now, perpendicular distance from the center, it is 3. So this distance will be 3. And this length is 8. So this length will be 4. That means radius of this circle will be 5. So we have to find this circle C2 with center at 5, 2 and radius equals 5. So equation of this circle will be x minus 5 square plus y minus 2 square, and that will be equal to 25, or we can write x square plus y square minus 10x minus 4y plus 4 equals 0, and that is the answer to this question. Now here the question is, if a variable line 3x plus 4y minus lambda equals to 0 is such that two circles, this first circle x square plus y square minus 2x minus 2y plus 1 equals to 0 with center at 1, 1 and radius equals 1, and this second circle with center at 9, 1 and radius equals 2 are on its opposite sides. Now first condition is these two centers, they lie on opposite side of the line. So that means if we want to put this point 3 plus 4 minus lambda and this other point 27 plus 4 minus lambda, their product, it should be negative. That means lambda minus 7 into lambda minus 31, it should be less than 0, or value of lambda should lie between 7 and 31. So that's the condition that centers lie on other side of the line. So that's our first condition. Now we have the second condition that these circles, they should not intersect this line. So if we take this first circle, then perpendicular distance from center must be greater than its radius. So perpendicular distance from center, this is 3 plus 4 minus lambda upon 5, it should be greater than 1. And in the same way for the second one, we'll get perpendicular distance from center, so there will be 27 plus 4 minus lambda upon 5, it should be greater than 2. Now we'll simplify these two conditions. This is mod of lambda minus 7 greater than 5, and here will be lambda minus 31 is greater than 10. Now this lambda is greater than 7 and it is less than 31. So here we'll get lambda minus 7 is greater than 5, or lambda is greater than 12. And here these circles, they may also touch this line. So we're going to include this equality sign at both the places. So lambda should be greater than or equal to 12, and here lambda minus 31 will be negative. So it will be minus lambda plus 31, it is greater than or equal to 10, or lambda is less than or equal to 21. So this lambda, it should lie between 12 and 21. That means answer to this question is this option C. Now here the question is, tangent and normal at this point to this circle and x-axis form a triangle. The area of this triangle in square units is. Now we have this circle with center at origin and radius equals 2. And we have this point which is root 3, 1. Now normal at this point will pass through origin and this radius is 2, and this angle, it is 30 degrees, and this is your tangent. We will find area of this triangle. Now we know that if this is x, then x cos 30 is 2 and cos 30 is root 3 by 2. So this x is 4 by root 3. Now area of this triangle is half 2 into x into sine 30. So this is 1 by 2 into 2, and x is 4 by root 3 and sine 30 is 1 by 2. So this value will be simply 2 by root 3. So area of this triangle is 2 by root 3 square units, and that's your option C. Now here the question is, find the equation of tangents drawn from the origin to this circle, and center of the circle is at minus r minus h, and its radius is r. So this circle, it touches y-axis. So this is minus r minus h, and this is r. Now if we put origin in this equation, we get s1 as h square, which is greater than 0. That means two tangents can be drawn from origin to this circle. Now one of the tangent is clearly y-axis, and equation of y-axis is x equal to 0. So one of the option is this option A, and then we have this other tangent passing through origin. Now we can write this equation as x plus r square plus y plus h square, and that will be equal to r square. Then equation of tangent is given by y plus h equals m x plus r plus minus r under root 1 plus m square. Now we need that tangent which passes through origin. So we'll put x as 0 and y as 0. So we'll get h minus m r, it is equal to plus minus r under root 1 plus m square. So we square it, we get h square plus m square r square minus 2 h r m, and it is equal to r square plus r square m square. Now this r square m square will cancel. So here we get this m as h square minus r square upon 2 hr. Now equation of this line is simply y equals mx as it passes through this origin. So equation of this line will be y equals h square minus r square upon 2 hrx, or this equation will be h square minus r square x minus 2 hry equals 0, and that's your option C. So the correct options are A and C. Now in this question we are given two lines, and we are given this circle whose center is at 3, minus 5, and its radius, it will be 2 units. Now L1 and L2 are basically parallel lines, and distance between these two parallel lines, it is given as 6 upon 4 plus 9, which is 6 by under root 13. Now we'll begin with the statement 2. Now 6 by root 13 is nearly 1.66 something. Now suppose this is L1 and this is L2. That says if L1 is diameter of circle C, then L2 is not chord of a circle. Now if L1 is diameter, and we know that radius of the circle is 2 units, whereas distance between lines is only 1.66. That means this L2 will always be a chord of the circle. So that means this statement 2 is incorrect. Now statement 1 is, if line L1 is a chord of circle, then L2 is not always diameter of circle C. Now we can draw a circle with L2 as diameter, and for which this L1 will be a chord, and there can be other circles where L2 is not a diameter, where L1 still be a chord of this circle. So that means this statement 1, it is correct. So answer to this question is statement 1 is correct and statement 2 is incorrect, and that's your option C. Now here the question is, two parallel chords of a circle of radius 2 are at a distance root 3 plus 1 unit apart. If the chords subtend at the center angle pi by k and 2 pi by k, then the value of greatest linear function of k is. So for this question, we have a circle whose radius is 2 units, and then we have two chords which are at a distance of root 3 plus 1 unit. Now we are given that these chords, they subtend angles pi by k and 2 pi by k at the center. Now this radius, it is 2. Now if we draw a perpendicular, suppose this is AB and this is O, then this angle, it is pi by k. So this AO is 2 cos pi by k. In the same way, this angle is pi by 2k and this is 2. So this BO is 2 cos pi by 2k. Now suppose pi by 2k is some angle theta. So we can write AO plus BO. So it will be this 2 cos 2 theta plus 2 cos theta. It is equal to root 3 plus 1. Now cos 2 theta is 2 cos square theta minus 1. So there will be 4 cos square theta plus 2 cos theta. And then it will be this minus 2 minus 1. So there will be minus 3 minus root 3 equals 0. Now this is basically a quadratic equation in 2 cos theta. So it will be this 2 cos theta square plus 2 cos theta minus 3 plus under root 3 equals 0. Now we can write 2 cos theta as minus b plus minus b square minus 4 ac whole divided by 2. Now this is minus 1 plus minus under root 1 plus 12 plus 4 root 3 upon 2, and this basically is a perfect square. So we can write 2 cos theta as minus 1 plus minus, and here it will be 1 plus 2 root 3 whole square upon 2. Now here pi upon 2k, it is an acute angle, so we are going to take only positive value. So it will be this minus 1 plus 1 plus 2 root 3 upon 2. Now this minus 1 plus 1 will cancel, this 2 will also cancel. So we get cos theta as root 3 by 2. That means this theta is pi by 6. Now we have taken theta as pi upon 2k. So it is pi by 2k. That means value of k is simply 3. So greatest linear function of value of k is 3. And that is the answer to this question. Now here the question is, a variable straight line through this point A is drawn to cut the circles at points B and C. So we have this circle x square plus y square equals to 1, and then we have this point minus 1 comma 1 which lies outside this circle. So this is your point A, minus 1 comma 1, and it intersects this circle at B and C, and there is any general point P on this line which is suppose at a distance R from A, and also let distance of B from A is R1 and distance of C from A is R2. Now we can write parametric equation of this line passing through A. So this equation will be x plus 1 upon cos theta equals y minus 1 upon sin theta, and will be equal to R. So coordinate of any general point P will be minus 1 plus R cos theta and 1 plus R sin theta. Now we need these points B and C which lie on the circle. So this general point, it will lie on this circle, so from here we can write minus 1 plus r cos theta square plus 1 plus r sin theta whole square, that is equal to 1. Then we square it, we'll get 1 plus, now r square cos square theta plus r square sin square theta will be 1, and then we'll have plus 2r, and here it will be minus cos theta plus sin theta, and it is equal to 1, and here we'll have one more plus 1, so this plus 1 and plus 1 will cancel. So basically we'll get a quadratic equation in R, and that will be given by r square plus 2 sin theta minus cos theta r plus 1 equals 0. Now this equation will have two real roots, r1 and r2. Now basically r1 into r2 will be 1, and r1 plus r2 will be 2 cos theta minus sin theta. Now we'll come to P in the context of this question, AB, AP and AC. So suppose we have this point P whose distance from A is R3. So now we can write coordinate of this point P as minus 1 plus R3 cos theta and 1 plus R3 sin theta, and we have to find locus of this point P. So since it is a locus problem, we'll take this point as alpha beta. So this point is alpha, this point is beta. So we'll get R3 cos theta is alpha plus 1 and R3 sin theta is beta minus 1. Now we can start solving the question. Now this first part is we have to find locus of P if AB, AP and AC, they are in AP. That means R1, R3 and R2, they are in AP. Now basically R3 is R1 plus R2 by 2. Now R1 plus R2 we have already worked out. This R1 plus R2 is 2 cos theta minus sin theta upon 2. Now this 2 and 2 will cancel. Now we multiply everything with R3, so we can write R3 square will be equal to R3 cos theta minus R3 sin theta. Now we can calculate R3 square by squaring and adding them. So it will be this R3 square, and we can write this as alpha plus 1 square plus beta minus 1 square. So it will be this alpha plus 1 square plus beta minus 1 square, and R3 cos theta, it is alpha plus 1 minus, and R3 sin theta is beta minus 1. Now we can write this as alpha square plus 2 alpha plus 1 plus beta square minus 2 beta plus 1, and there will be alpha plus 1 minus beta plus 1. Now plus 1 and plus 1 will cancel. So this required locus will be alpha square plus beta square, this plus alpha and then minus beta equals 0. So locus of this point P will be a circle whose equation is x square plus y square plus x minus y equals 0. Now it says D be the minimum distance of origin from locus of P. So we have to find minimum distance of origin from this locus. Now as we can see, this circle, it passes through origin, so its minimum distance is simply 0. So this A, it matches with B. So A, it matches with P. Now second part is AB, AP and AC, they are in GP. So for part B we have AB, AP and AC, they are in GP, that is R1, R3, R2, they are in GP. Now that means R3 square equals R1 into R2, and we know that R1 into R2 is 1. So basically it will be this R3 square equals 1 and R3 square is this value. We'll get this equation as alpha plus 1 whole square plus beta minus 1 whole square, and it is equal to 1. Now basically it is a circle whose center is at minus 1, 1 and which touches both the axes. Now we have to find minimum distance from origin. Now distance of center from origin, it is root 2 and its radius is 1. So this minimum distance, it is root 2 minus 1. That means this B, it matches with S. So B, it is going to match with S. Now the C is AB, AP and AC, they are in HP. So we have this C where AB, AP and AC, they are in HP, or R1, R3, R2, they are in HP. Now here R3 is 2 R1 R2 upon R1 plus R2. Now this is R3, R1 into R2 is 1 and R1 plus R2 is 2 cos theta minus sin theta. Now here 2 and 2 will cancel, so we'll get this as R3 cos theta minus R3 sin theta, and it is equal to 1. Now R3 cos theta is alpha plus 1 and R3 sin theta is beta minus 1 and it is equal to 1. So this required locus will be alpha minus beta plus 1 equals 0. So locus of this point P will be this straight line x minus y plus 1 equals 0. Now perpendicular distance from origin will be equal to 1 by root 2. So this C, it matches with Q. C, it matches with Q. And then AB, AP by 2 and AC, they are in AP. It says for this D, AB, AP by 2 and AC, they are in AP. That means R1, R3 by 2 and R2, they are in AP, or R3 is simply R1 plus R2. Now this is R3 and this is 2 cos theta minus sin theta, or we can write R3 square equals 2 R3 cos theta minus R3 sin theta. Now R3 square is alpha plus 1 square, and this is beta minus 1 square, and this is 2 alpha plus 1 minus beta minus 1. Now this equation will be alpha square plus beta square plus 2 alpha minus 2 beta plus 2, and here will be this 2 alpha minus 2 beta plus 4. Now 2 alpha 2 beta will cancel, so this equation will be alpha square plus beta square equals to, or locus of this point P is now this circle, which is x square plus y square equals 2. Now in this case distance from origin is basically its radius, which is root 2. So now d is root 2. That means this d, it matches with r. So this d, it matches with r. So answer to this question is PSQR. Now the question is the set of values of c so that y equals mod x plus c and this circle which is x square plus y square minus 8 mod x minus 9 equals to 0 have no solution. So what we'll do is we'll find the point of intersection. So we'll replace y with mod x plus c. So it'll be this x square plus, and then here will be this mod x plus c whole square minus 8 mod x minus 9 equals 0. So it'll be this x square plus c square plus 2c mod x minus 8 mod x minus 9 equals 0, or it will be this 2x square plus 2c minus 8 mod x plus c square minus 9 equals 0. Now this equation should have no solution. Now this is not a normal quadratic equation, it is a quadratic in mod x. So this equation will have no solutions in two cases. Case 1, if d is less than 0, if there are no real roots, or if d is greater than or equal to 0, but both the roots alpha beta, they are less than 0. So if roots are less than 0, then mod x equals negative value will give us no solution. So these are the two cases possible. Now we'll evaluate this first case when d is less than 0. So it will be b square. So this is 4 c minus 4 whole square minus 4 2 into c square minus 9. It should be less than 0. Now this 4 and 4 will cancel. We'll get c square plus 16 minus 8c minus 2c square plus 18 should be less than 0, or we can write c square plus 8c minus 34 is greater than 0. Now we'll add 16 and we'll subtract 16. So we'll write c plus 4 whole square, it should be greater than 50, or mod c plus 4, it should be greater than under root 50. So here we'll have two conditions. Either c plus 4, it is greater than under root 50, or c plus 4 is less than minus root 50. So the condition that we get here is either c is greater than minus 4 plus under root 50, or c is less than minus 4 minus under root 50. So this is one condition. Now this other condition is when d is greater than or equal to 0. Now d is greater than or equal to 0 if c lies between minus 4 minus under root 50 and minus 4 plus under root 50, and both the roots are negative. That means sum of roots alpha plus beta is less than 0 and alpha into beta is also less than 0. Now in this case, sum of roots is minus b upon a. So it will be this minus 2c minus 8 upon 2. It is less than 0. That means c is greater than 4. And here alpha beta is less than 0. That means c square minus 9 is less than 0. That is, value of c should lie between minus 3m plus 3. Now intersection of all these three conditions is phi. So basically this case is not possible for this quadratic equation. So answer to this question is either c is greater than minus 4 plus root 50 or it is less than minus 4 minus root 50. Now here the option given is this option D, which is c is greater than minus 4 plus root 50. Now here the question is, a ray of light is incident at a point minus 2, minus 1 and gets reflected from the tangent at 0, minus 1 to this circle. The reflected ray touches the circle. The equation of line along which the incident ray moved is. So we have this circle with center at origin, and radius equals 1, and says it gets reflected from the tangent at 0, minus 1. So this tangent is at y equals minus 1 line. That is, we have this incident ray which passes through minus 2, minus 1, and the reflected ray is tangent to this circle. Now this ray of light is incident at this point minus 2, minus 1. So this point is minus 2, minus 1. Basically, which is a point of incidence. Now what we'll do is we'll write equation of tangent to this circle in terms of its slope. So this is y equals mx plus minus r under root 1 plus m square, and we need the tangent which passes through minus 2, minus 1. So we'll put x as minus 2 and y as 1. We'll get 2m minus 1 equals plus minus under root 1 plus m square. Now this is 4m square plus 1 minus 4m, and this is 1 plus m square. Now this 1 and 1 will cancel. So we'll get this value as 3m square minus 4m equals 0. So either m is 0 or m is 4 by 3. Now slope of reflected ray is 4 by 3, and we know that if this angle is theta, this angle is also theta. So this angle is pi minus theta. So slope of incident ray is minus 4 by 3. Now once we have point and slope, we can write its equation. So it will be this y plus 1 minus 4 by 3 x plus 2. So it will be this 4x plus 3y plus 11 equals to 0. That's your option B. Now the question is, consider the relation 4l square minus 5m square plus 6l plus 1 equals 0. Then this line lx plus my equals to 1 touches a fixed circle. We have to find center and radius of this circle. So we are given this line lx plus my equals 1. Now let the circle be x square plus y square plus 2gx plus 2fy plus c equals 0. Now center is minus g minus f, and radius is under root of g square plus f square minus c. Now this line, it is tangent to this circle. That means perpendicular distance from the center must be equal to its radius. So we can write minus lg minus mf plus 1 upon under root of l square plus m square, and that will be equal to its radius, which is under root of g square plus f square minus c. Now we'll square it. L square g square plus m square f square plus 1 plus 2 lmgf minus 2 lg minus 2 mf, and it will be equal to g square l square plus g square m square plus f square l square plus f square m square minus c l square minus c m square. Now here g square l square will cancel, and m square f square will also cancel. So we can rewrite this as f square minus c L square plus g square minus c m square minus 2 ln gf plus 2 gl plus 2 mf minus 1 equals 0. Now what we'll do is we'll make it plus 1 because in the condition they have given it as plus 1. So we'll change the sign of each term. So here it will be this plus 1. So this is minus, minus, plus. This is minus g square plus c and minus f square plus c. I will compare it with the given condition, which is 4l square minus 5m square plus 6l plus 1 equals 0. And we compare this plus 1, so we'll get c minus f square equals 4, c minus g square equals minus 5. Now there is no term containing m, so that means f must be 0. So from here we get f as 0. C equals 4, and if we put c as 4, we'll get g as plus or minus 3. Now we compare this 6l with minus 2gl, we'll get this g as minus 3. So value of g is minus 3. So once we have g, f and c, center of the circle is minus g minus f. So here g is minus 3, f is 0 and c is 4. So equation of this circle will be x square plus y square minus 6x plus 4 equals 0. And center is at 3, 0 and its radius is root 5. And that's your option C. Now the second one is number of tangents which can be drawn from the point 2, minus 3. So we'll find S1. So there will be 4 plus 9, 13. 13 minus 12 plus 4, which is positive. So this point, it lies outside. So that means 2 tangents can be drawn. So answer to the second question is this option C. Now third one is from this point 2 tangents are drawn, PA and PB. And we have to find the value of PA into PB. Now P into PB is basically under root S1 square. So this is under root 5 and under root 5. So it will be simply 5 and that's your option B. Now here the question is, we are given 2 fixed points A minus 2, 0 and B 2, 0 such that PA minus PB it is equal to 2. Now we know that if this is the condition, then it represents which opens towards the right. So this locus will be this branch of hyperbola where the two focus are minus 2, 0 and plus 2, 0. And we have this circle which is x square plus y square equals r square. Now using this information, we have to match column 1 with column 2. Now in A it says, if r is 2, then number of points P satisfying this hyperbola and circle is. Now if r is 2, then this circle will be drawn like this. In that case, it is going to intersect this hyperbola branch at 2 points. So number of points P satisfying both the equations is 2. That means this A, it matches with P. Now A matches with P is only one option. So answer is this option D. Now we have to find if R is equal to 1, then number of points satisfying the two equations. Now for this hyperbola, PA minus PB is 2A. So that means A is 1 and distance between focus is 4. That means 2AE. It is 4. So value of E is simply 2. Now we can find b square, and there will be a square into e square minus 1. So this value, it is 3. So equation to this hyperbola is x square upon 1 minus y square upon 3 equals 0. So this point, it is at 1, 0. Now if we draw a circle with radius 1 unit, it is going to touch this hyperbola at 1, 0. So there will be only 1 point. So this b, it matches with S. Now the C is for r equals to number of common tangencies. Now if we take r as 2, then for the C part, equation of circle is x square plus y square equals 2 square, and equation of hyperbola is x square minus y square upon 3 equals to 1. Now equation of tangent to this circle will be y equals mx plus minus r under root 1 plus m square, and here for this hyperbola it will be y equals mx plus minus under root a square m square minus b square. Now these two, they should be same, so we get 2 under root 1 plus m square, it should be equal to m square minus 3. So this is 4 plus 4m square, and it is equal to m square plus 3, or m square equals minus 7 by 3, which is less than 0. So no tangent is possible. So in this case, number of common tangents will be simply 0. So the C, it matches with R. And for r square equals 1 by 2, number of common tangents is. Now if we have r square as 1 by 2, then tangent to this circle will be y equals mx plus minus 1 by root 2 under root 1 plus m square, and hyperbola will be same, y equals mx plus minus under root m square minus 3. Now if we equate them, we get 1 by root 2 under root 1 plus m square, it should be equal to under root of m square minus 3. Now this is 1 plus m square, and here will be 2m square minus 6, or m square is 7. Now in this case, we'll have two values of m, plus under root 7 and minus under root 7. So in this case, the number of common tangents will be 2. So this D, it matches with P. And that is the answer to this question. Now here the question is, a circle of radius 1 is inscribed in an equilateral triangle PQR. The points of contact of C with the sides PQ, QR and RP are D, E and F respectively. The line PQ is given by the equation root 3x plus y minus 6 equals 0, and the point D is 3 root 3 upon 2 and 3 by 2. Further, it is given that the origin and the center of the circle are on the same side of PQ, then which of the following they are correct. So we have this triangle PQR, and there is a circle C which is inscribed in it. So what we'll do is, we'll first draw this circle C, and then we have this triangle PQR. So this is P, this is Q, and this is R. This is the circle C. Radius of the circle is 1 unit. The point of contact of C with the sides PQ, QR and RP are D, E, F. So this is D, this is E, and this is F. And we are given this line PQ, and PQ is root 3x plus y minus 6 equals 0, and coordinate of this point D, it is 3 root 3 by 2 comma 3 by 2. Now let the center be h comma k, and we know that perpendicular distance from the center or foot of perpendicular from center on this line will be equal to coordinate of this point D. So we'll straight away use foot of perpendicular formula. Now perpendicular distance from the center, it is equal to radius, so we'll get mod of root 3h plus k minus 6 upon 2 and it'll be equal to 1, and we know that foot of perpendicular from center to this PQ will be this coordinate D. So we can straight away write 3 root 3 by 2 minus h upon root 3, it is equal to 3 by 2 minus k upon 1, and it'll be equal to minus, and then it'll be this root 3h plus k minus 6 upon 4. Now we know that root 3h plus k minus 6, it is equal to plus or minus 2. So then this value will be plus or minus 1 by 2. Now if we take this plus sign, then we'll get 3 root 3 by 2 minus h is equal to root 3 by 2. Then value of h will be root 3. And here 3 by 2 minus k, it is equal to 1 by 2. Then the value of k is 1. So this center will be at root 3 comma 1. And if we take this minus sign, then we'll get 3 root 3 by 2 minus h minus root 3 by 2 and 3 by 2 minus k, it is equal to minus 1 by 2. Now in this case, value of h is 2 root 3 and value of k is 2. Now in the question, additional information is given that origin and center, they lie on the same side of PQ. Now if we look at equation of PQ, it is root 3x plus y minus 6 equals 0. If we put x and y as 0, we'll get this as minus 6, which is less than 0. So out of these 2 points, we have to choose the point for which this value is negative. Now if we put root 3 comma 1, we'll get this as 3 plus 1 minus 6, which is minus 3, less than 0. So this point, root 3 comma 1 and origin, they lie on the same side. And if we take 2 root 3 comma 2, then this value will be plus 2, which lie on the other side of origin. So in this case, center of this circle is at root 3 comma 1. So this center, it is at root 3 comma 1. Now once you have center and radius, we can write equation of this circle. So equation of this circle is x minus root 3 whole square, y minus 1 square, and it will be equal to 1. And that's your option D. Now the next question is, we have to find these points E and F. Now what we'll do is, we'll locate the circle more precisely on coordinate axis. So we can draw it like this. Now we know that this angle is 120 degrees. Since this equation is root 3x plus y minus 6 equals 0, slope is minus root 3, that is 120 degrees. Now the other two sides, they'll make an angle 60 degrees. So one of the side will be x-axis, and we'll have this other side here, which is going to make an angle 60 degrees. So we have to find these 2 points. Now say this is E and this is your point F. Now center of this circle, it is at root 3 comma 1, and this is your point D. This is P, Q and R. Now we know that this is x-axis, so this line will be perpendicular to x-axis. So coordinate of this point F will be root 3 comma 0. So coordinate of this other contact point F, it is at root 3 comma 0, and we have to find coordinate of this point E. There are many ways to solve this, and one of the ways, we can draw this line, say CE. Now this angle is 60 This is 90. That means slope of this line is root 3 and slope of EC is minus 1 by root 3. Now slope is minus 1 by root 3. That means theta is 5 pi by 6. Now what we can do is we can write equation of this line EC in terms of parametric coordinates. So this equation will be x minus root 3 upon cos 5 pi by 6, and that is under root 3 by 2 y minus 1 upon sine 5 pi by 6, which is 1 by 2, and will be equal to plus or minus 1. Now if we take this plus sign, we'll get this as x equals root 3 minus root 3 by 2 and y minus 1 equals 1 by 2. So this point will be root 3 by 2 and 3 by 2. And if we take minus sign, then we'll get this point as x as 3 root 3 by 2 and y as 1 by 2. So basically there will be 2 points. This is E dash. I will discard E dash. We need this point E, and this point E will be this root 3 by 2 and 3 by 2. So that's your point E. So coordinate of this point E will be root 3 by 2 comma 3 by 2, and F is root 3 comma 0. That means the correct option is this option A, root 3 by 2 comma 3 by 2 and root 3 comma 0. And finally it is equation of sides QR and RP. Now equation of RP is very simple. It is simply x-axis. So its equation is y equals to 0, and equation of QR is y minus y1 equals root 3 x minus root 3 by 2. So it will be this y minus 3 by 2 equals root 3x minus 3 by 2. So equation of QR is root 3x minus y equals 0, and equation of PR is y equals 0. So the equations are root 3x minus y equals 0 and y equals 0. And there will be your option D, root 3x minus y equals 0 and y equals 0.